So I put them in last night. So if you haven't looked it up, you can, and then during work time today, remind me and I'll show you your test too, okay? All right, so today what we're gonna do is a little bit different than yesterday. So they're gonna give us a scenario, and so in this situation, they say the sum of two odd numbers. So they want us to do some examples where we find the sum of two odd numbers, any two odd numbers that you want to, and then try to come up with a conjecture about those, something that's true about all of them, okay? So if I go down here, it says find 4 or 5 examples and try to find a pattern. So we're gonna, sum means add, right? And we're gonna add together any two odd numbers, doesn't matter. So I'm gonna start with 1 plus 3, okay? And that's 4. Then maybe you wanna do 5 plus 7, and that is 12. Maybe you wanna do 13 plus 7, and that's 20. You could do 15 plus 9. That's 24. Do you notice anything about those 4 numbers?
They're even.
They're all even numbers. So you could keep trying and keep trying examples, and any time you add together 2 odd numbers, you're gonna get an even number. So your answer here would just be even. So anytime you add together 2 odd numbers, you are going to get an even number, okay? All right, so now let's look at this one. This isn't the best example here. This gives us a statement. It says segments joining opposite vertices of a rectangle. So segments joining opposite vertices are called diagonals. And what would you guys think you would find out if you measured these diagonals in all of these cases? What do you think would be true? They're equal, right? And that is something that is true. Like I said, I don't really love this example, but yes, if you tried these, all of these diagonals would be equal. So that would be your answer. Okay, then it says the relationship between AB and EF if AB equals CD and CD equals EF. So they're telling us AB equals CD and CD equals EF. If I drew that out, let's say this is AB, this is CD, and then I also need EF. Okay? What happens here is they're telling us that AB equals CD. Then they're saying that CD equals EF. So then these two are equal. And what we want to do is come up with some relationship between these two. What would you think? If this equals this and this equals this, what would you think about these two? They would be equal also, right? So our answer here would just be that AB equals EF. Okay. Now this next one says the sum of the squares of 2 consecutive whole numbers. Just so you guys know what whole numbers are going to be like 0, 1, 2, 3, 4, 5, okay? And we want two consecutive whole numbers, so that just means it would be like 1 and 2 or 4 and 5. They'd be right next to each other. And we want to find the sum of the squares of two consecutive numbers. So let's try 1 squared plus 2 squared. 1 squared is 1, 2 squared is 4, 1 plus 4 is 5, okay? Then let's try 2 squared plus 3 squared. You can try any two consecutive numbers. So 2 squared is 4, 3 squared is 9, 4 plus 9 is 13, okay? Then I have, let's try 4 squared plus 5 squared. This is 16 and this is 25, and that would be 41. Okay, let's try 5 squared plus 6 squared. So this is 25 plus 36, which would be 61. Okay, so do you notice something that's true about all 4 of those? They are all odd, right? So our answer here would just be odd. That's all we would write out. Okay? And you're just coming up with those 4 or 5 examples to be able to tell if that is true. And it can be any examples. Okay? Now it says the sum of a whole number. Or I'm sorry, the square of a whole number. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. And then let's do 6 squared too. Okay? I'll give you a hint on this one. This has 2 separate rules. Anyone notice? I'll give you a rule or a hint. It has one rule for, oh, go ahead. Yes, absolutely. If the number is odd, it's odd. If the number is even, it's even. Very good. So we're gonna say if number is odd, square is odd, if number is even, square is even. All right, now this next one says we have points L, M, and N. Now, when you have something like that, where you have 3 points, there's one of 2 ways that it could be. You could have your 3 points in a triangle where they would be non-collinear, that's one thing, or you could have them all on the same line where they're collinear. Now, you're given 3 points. How you determine which points are on the endpoints is by looking at the biggest number here. From L to M is 20, which is the biggest. So what that tells us then is I could call that L and that M, and they're telling us this is 20, okay? Now that leaves N for being in the middle, okay? Then they say MN is 6, and L to N here is 14. Now I obviously didn't draw it to scale. Here is how you can tell if they're non-collinear, kind of in a triangle, or collinear, where they're all on the same line, is you draw it out like this, and if the 14 plus the 6 equals 20, which it does, that means all of your points are on the same line. If this was like 10, 6, and 20, that would tell you that it would be where your 3 points would not be on the same line. Okay? So what we would write for our answer here is L, M, and N are either, you could say, on the same line or collinear. Okay, bless you. Now if we go down here, it says points A, B, and C are collinear. Okay, so we're gonna draw a line. And collinear means on the same line. So we're gonna have a point A, a point B, and a point C. Okay? Now it says D is between B and C. For D to be between B and C, it would also be on that line. Okay? So now we have to say something else about that. And what do you think we could say about all 4 points now? They are collinear or on the same line. Okay? So let's write that up. A, B, C, and D are, you could say, on the same line or collinear. Okay. All right, now let's look here. And this one says point P is the midpoint of NQ. So if you think of what midpoint means, that means that this part is congruent to that part, okay? Does everybody understand that with midpoint? And what you have to do now is say something else about that. And one thing I'll tell you is sometimes more than one answer would work. Like somebody could say here, N, P, and Q are collinear, and that's true, okay? But a more specific thing that I would like you to say when it's a midpoint is that NP is congruent or equal to PQ. So like I said, there are different things sometimes that you can say about that. If there's one that is more specific, I'd rather you go with that. But if I gave this on the test and you said N, P, and Q are collinear, I would accept that, okay? Questions on any of that? Okay, let's go to this page. So this is kind of the same thing. We're gonna draw this out and we're gonna try to make a statement about it, okay? And again here, things can, you can have more than one answer. So this tells us point S is between R and T. Okay? When you do this, one of the things you could say is R, S, and T are what? Collinear, right? Another thing that we could say that maybe you would do, I'm not sure, this one might be a little bit less likely for you guys to say, but you could say RS plus the distance from S to T would equal the distance from R to T. Okay, but that's just one. If you wouldn't have to have that one, like I said, you also could have R S and T are collinear. Okay. All right. So now let's look at this one. It says angle RST is a right angle. So let's draw a right angle. So hopefully you would know to put the box there. Do you guys know if S is in the middle, that would be this point, bless you? And then we could put the R here and the T here. Okay, so we drew it out and now we have to say something about it. What would be true if that's a right angle? How many degrees would it be? 90, right? So we can just say the measure of angle RST is 90. So that might be like, oh, that's so obvious, but you're just saying something else about it that's true. Okay? Now, if you look at this one, they have two angles that are vertical. And notice in this that both angles have B in the middle. So vertical angles are always formed when you have two intersecting lines. So I'm going to draw that. The B is in the middle of both angles. So that tells me this point right here is B. Okay? And then I could put the A and C. I think I'm going to put A here and C here. And then I'm going to put D here and E here. So here are the two angles that are vertical. Angle ABC, which is this one, and angle DBE, which is this one. Okay? Now again, what do we know about vertical angles? We know they are equal. So what we could say here is either the measure of angle ABC equals the measure of angle DBE, or you could say that angle ABC is congruent to angle DBE. So usually when it's congruent, you don't have the M's. I shouldn't say usually. When you use congruent, you don't use the M's. When you use the equal sign, you do use the little M's for measure. So here are two different ways we could write that. Okay. Now if we go down here to one that has a graph, they are telling us that we have a point A that is at -1, -1. So let's plot that point. Then we have B that's at 2, 2. And then we have C that's at 4, 4, right there. Okay? Now, does anyone see something that's true about those 3 points?
It's 180 degrees.
Say that again?
It's 180 degrees.
Yeah, that's true. Like if you connected them, it would be 180 degrees. Absolutely. Yep.
Maybe collinear.
Yes, that's the other thing you could say. So like I said, sometimes you can have more than one answer. So we could just draw a line through these. Okay. And we can say over here that A, B, and C are collinear. And then it would be true what Isla said too, that you could say the measure of angle ABC is 180 degrees. Okay? So you have to be confident sometimes that there's more than one answer. Thank you. Let me get you the notes here. Oh, you have them from yesterday. Were you here yesterday?
Yes.
Okay. All right, so let's go to our last page here. And the last thing that we're gonna do is they're gonna give us a statement and we have to decide if it's true or false, okay? If it's true, all we say is that it's true and that we're done. If it's false, they're gonna ask us to give a counterexample, okay? Let's say, so in 8th grade in the fall, are most of you like 13, 14, 13? 12? Is it 13? 13. And are some of you 14 already? No? You are? Okay. So say I said, my 8th grade advanced geometry students are 13 years old, okay? If there's one kid that's 12 or 14, that would be a counterexample and it would make it false. You only need one situation that's false to make it be an overall false statement, okay? So let's go here, and what they're saying is if n is a real number, then n squared is greater than n. Now, first of all, real numbers, you guys, are positive numbers, negative numbers, zero, fractions, decimals, irrational numbers, all of those are real numbers, okay? So when you try these out, you want to try like a positive number first. If it works for 2, it's going to work for 4 and 6 and 9 and 20, okay? If it works for a positive number, then try a negative number and see if it works. If it works for both of those, try 0. If it works for all of positive, negative, 0, then I would try a fraction or a decimal, okay? So let's try a positive number first. Let's try 2. Is 2 squared bigger than 2? Yes, okay. Now let's try a negative number. Is negative 3 squared greater than negative 3? Now, do you guys know when you square a negative, it's positive. So when you square a negative 3, it's 9. And 9 is bigger than negative 3, right? Then we've tried positive, we've tried negative, then let's try 0. Is 0 squared bigger than 0? No. That's one counterexample. So what you could do is say false, and this would be your counterexample. Okay? Now maybe somebody else tried a fraction instead, and they went and tried 1/2. 1/2 squared, is that bigger than 1/2? Do you guys know when you square a fraction, square a fraction, you can square the top, 1 squared is 1, and then square the bottom, 2 squared is 4. Is 1/4 greater than 1/2? No. So this would be another counterexample. So when you're given a counterexample, you only have to do one of them, okay? All right. Now let's look here. And we have S, T, and U are collinear, which means they're on the same line, and ST equals TU. So S, T, and U are collinear, and ST equals TU, okay? Is T the midpoint of SU then? Yes. Okay, in your assignment today, so this one we just write true and that's all we have to do, okay? In your assignment today, you're gonna have a question that's just like this, but the collinear part is out, and I believe the same question is on your quiz that'll come up after MEA break. The part that says collinear is necessary here for this to be true. And it's kind of a trick question, but if ST and U are not collinear, it can look like this, ST, U, and those two are equal, but T is not the midpoint, okay? So the fact that this problem told us that ST and U are on the same line is critical for that being a true statement. And in your homework tonight, I believe they have one like this where it doesn't say they're collinear, okay? Then it says if N is a real number, so again that means positive, negative, zero, fraction, decimals, then negative N is a negative number, okay? So if we try 2, negative 2 is a negative number, okay? If we try 0, there's really not a negative 0 anyway, right? But would that be a negative number? Is there a negative 0? There's really not, okay? If we tried negative 2, what's negative a negative 2? A positive 2. So is that a counterexample right there, right? Because I put in a negative number, and when I did the opposite of it, I got a positive number. So I'm going to write false, and then I always have to give a counterexample, which is right here. Okay. Now D, if we look at this one, gives me 2 vertical angles, okay? I can draw this out. If you knew this without drawing it out, you wouldn't have to draw this, okay? But they're saying A, B, C, and D, B, E are vertical angles, okay? Remember, vertical angles are angles that are across from one another. If they're vertical, could we say that those two are congruent? Yes. Isn't that what vertical means? So like I said, if you didn't mean to draw that one out, you wouldn't have to, and you could just write true. Okay. Now, E, think about this. If you have 2 angles that are supplementary, do they form a linear pair? Do they have to form a linear pair? Think about that. You know, if you have a linear pair of angles, like say I had this one and this one, they're going to be supplementary, right? Because they're going to add up to 180, and they're going to be a linear pair. But do you think all angles that add up to 180 have to be right next to each other? No, they don't. So you could have something that looks like this, where maybe this one's 120, and then over here you have one that is 60. They're still supplementary, but they're not together, so they're not a linear pair. So I write false, and this would be my counterexample. Okay. Then if we look at this one, it says DE, segment DE, is perpendicular to EF. So notice there's an E in both segments there. So that tells us the E would go right here. Okay, so I'm going to do DE and EF. And do you guys all know the upside down capital T means perpendicular? So that means this is 90 degrees. Can we say that angle DEF is a right angle? Yes. So all we have to do here is say true. perpendicular means that it's a right angle. Now, this one says we have two angles that are adjacent. Do you remember what adjacent means? Right next to each other. If two angles are right next to each other, do they have to form a linear pair? No, they could, right? But they don't have to. Could we have this, where this is angle 1 and this is angle 2, but together they don't form a line? That would be our counterexample, and then we would say false. Okay. All right. So I have a worksheet for you guys today, and I put the key on. Oh, I guess I didn't write it up. Oh, ignore this assignment. This is not right. All right, so it's a worksheet today. And I have a paper key that I'll set up here, as well as the key I believe is in Schoology if you wanted to pull that up. So it has some from each section that we did. So you don't need a piece of paper today, you'll just write right on the worksheet. Did you think it was hard today? So I have a key up here as well as a key in Schoology, okay?